Welcome to my channel. In a previous video, I was showing this version of my all-in-one filament jam and runout sensor using two microswitches. But I got a comment from Christophe who suggested me to find another system in which I will use only one single microswitch. That's what I did, and I'm going to show you the result. Thank you, Christophe. This is the result of the work. A smaller all-in-one filament jam RNA sensor using only one single microswitch. Let's see that. This is the new type of sensor I have created. We have the different parts here. Here is the cap. Here is the microswitch. Here we have the microswitch mount. This is the main part, and this is the gantry mount. And here we have two small pieces of PTFE tube. As you can see here, the microswitch has a hole on its basis here. This hole here. And this hole fits the axis we have on the main part here in the middle. This is how you place it on the main part. The hole fits the axis just like this. This allows the microswitch to pivot on this axis at a certain angle, just like that, for example. It can pivot just like this. The idea is when the filament is blocked and it tangles, it pulls on this axis here, and when it pulls on this axis, the microswitch pivots at a certain angle, just like that. And when it pivots, the arm of the microswitch moves up, creating the contact. After it returns to its initial position, thanks to this lever here that works like a spring. Here it is. Now, for the runout sensor, when filament is present, the microswitch arm is pushed down. But when there is no more filament, the arm of the microswitch moves up and creates the contacts. Now, another issue I noticed was that the microswitch arm tends to move up and down, just like this. It does not have a fixed position. It can move just like this. Now, to avoid that, I've put this small lap here, and it prevents the microswitch arm from moving upward when it is placed. Okay. For the installation, I first place the microswitch on its mount here. These wires go through this small hole at the bottom, just like this, and I place my microswitch. There it is. Now I can put the microswitch on the main part. These wires go through this hole here. Now I should make sure that this axis goes inside this hole. There it is. And here it can pivot, as you can see. Now I can place the cap. Now I take this small piece of PTFE tube, about 5 centimeters, and I will insert it here in this hole here. I push it all the way down. There it is. Now this longest part I insert it here. There it is. Now I can put two small screws here. Now to place it on the printer I need this mount. Here also there is a hole at the bottom for the wires to go in. Now this part with the longest PTF2 piece goes inside first. I can push it all the way down. There it is. And now I can place it on the printer. Just like this, I place it on the gantry here. Push it inside. And there we are. Now we can test it. Here we are on the printer. We're going to insert our filament. We're waiting for the print to start. There it is, it has started printing. Now I'm going to block the filament spool to simulate a filament jump. Now it's printing. There it is, it says filament runout jump. It's unloading the filament. There it is. Now I put back the filament and I press load to continue. That is, it has started printing again. Now I'm going to cut the filament to simulate a filament runout. I cut the filament here. There it is, it says filament runout jump. As you can see here, it writes filament runout jump. This is different from the previous firmware on which it writes filament runout only. Here you have filament runout jump. This is made possible thanks to a little change I made in the firmware. In the Explorer, I open Marlin folder, then SRC, LCD, I look for the folder dwin, and I open the file creality_dwin.cpp. Now I look for filament runout. I search for filament runout. It's on around line 5694. Here it is. Here it is, filament runout, around line 5694. I just add at the end /jump. This is the message that will be displayed when there is filament jump or filament runout. Now I save the file and I compile my firmware. There it is, the compilation is done. Now I can upload the firmware to my printer. Once again, thank you very much, Christophe, for your suggestion. And for those who want to support him or know more about him, you can click the link to his website in the description below. For those who are new to the channel, please make sure you subscribe and hit the notification bell for further videos. And for all others, do not hesitate to like and share the videos. Thank you very much.